All right, now at the end of the video from Sunday night, I told you that you wanted to do the first two problems for homework because I wanted you all to see what we would have in terms of our knowledge level. Okay, I wanted to see what you knew and what you didn't know. All right, now we are going to go ahead and continue into lesson 12. So we're going to list some examples of division problems that produce a quotient that is a negative number. Now, I want you to remember that when we were talking about multiplying integers, whenever you had a positive number times a negative number or a negative times a positive number, our answers were always going to be negative. Okay? Well, that rule actually applies itself to division problems as well. So the same rules for multiplication actually apply to division. So you could have 6 divided by a negative 2, and that would give us a negative answer. Or you could have a negative 12 divided by a positive 3. That would give us a negative answer. Okay? Or you could do negative 24 divided by 6. Okay? That would give us a negative number. Okay? Anytime you have a division problem or a multiplication problem where one of the integers is negative but the other is positive, you're going to get a negative answer. Okay, it's always going to be that way. There's no ifs, ands, or buts around it. That's the way it's going to work. Okay. Now, if the quotient is a negative number, what must be true about the signs of the dividend and divisor? Okay. Well, that's easy. The quotient, if you remember, is the answer. Okay, so if the answer is negative, then that means the dividend and divisor, one of them had to be negative. Has to be negative. Okay, that is true. Just like when we were doing with multiplication, one of the factors has to be negative in order for us to get a product that is negative. Okay, so the same thing applies here. One of the dividend or divisor has to be negative in order for us to get an answer that is negative or a quotient that is negative. Okay. List your examples of division problems that produce a quotient that is a positive number. You've done this since elementary school. Okay. 24 divided by 3. 100 divided by 10. Okay. 27 divided by 9. These are all examples of division problems that give us a quotient of a positive number. Okay, now these are not the only ones. You could do a negative 35 divided by a negative 5, or you could do a negative 50 divided by a negative 10. Okay, there are two different types of problems that gives a positive number, and we remember this when we were working with multiplication, because if we had the same sign, our answer was going to be positive. Same thing applies to when we're working with division problems. Okay, either both the dividend and the divisor have to be positive, or they both have to be negative in order for us to get an answer or a quotient that is a positive number. Okay, and that oddly enough is our answer for part D. Okay, both the dividend and divisor must be positive or negative. Okay, so they either both are positive or they're both negative in order to get a quotient that is positive. So, in other words, the rules for dividing two integers. A quotient is negative if the divisor and the dividend have right. Okay, they are if they have different signs. A quotient is positive if the divisor and the dividend have the same signs or identical signs. Okay, that's going to be important. That's the same rule for multiplication. That doesn't change. So don't sit there and sidetracked on me here, okay? All right. Is the quotient of two integers always an integer? Okay. Use the workspace below to create quotients of integers. Answer the question and use examples of counterexamples to support your claim. Okay. So is the quotient of two integers always an integer? Now remember, integers are going to be numbers that are both positive on the opposite of 0 and negative, which are going to be on the left of 0. Okay, so we need to know numbers that are not going to be considered integers. Okay, So the question then becomes, do we have anything that would not be considered an integer? Is there something that could not be written in the form of a fraction or a decimal? Okay. That is what I want y'all to work for homework tonight. That's the kind of question I want to know. I want to see if you can provide me an answer, okay, where you cannot create an quotient that is an integer. Okay, see what you come up with. All right, exercise 3. Different representations of the same quotient. Okay, this is easy. So we have a different signs, okay? Negative 14 divided by 7. If we have different signs, then we know our answer is going to be negative, okay? But this is going to be the, what is it, the dividend and the divisor, okay? So the dividend is negative and the divisor is positive. But 14 divided by 7 we know is 2, but the negative is still there, so it's a negative 2. Now we've got the divisor that is positive and the dividend that is negative. So 14 divided by a negative 7. Positive divided by a negative gives us a negative. 14 divided by 7 is 2. Again, negative 2. Oh, look at this one here. This one's an interesting problem. Okay. Do they get the same or different quotients? All right, now, okay, this is where things can kind of get a little interesting here, okay? Because, all right, the problem is since you got the parentheses, it really does change things around a little bit on us, okay? Do we get a positive or do we get a negative 2? Okay. Now, we have to follow Pemdas. Okay. Whenever we work with something like this, we have to follow the rules of Pemdas. Okay, or our order of operations. And in this case here, the parentheses comes before the division. Okay. So we have to do the parentheses. 14 divided by 7 is 2. Negative, and then parentheses 2. Now I can do the multiplication. Okay. What do you mean, Mr. Hale? There's multiplication here? Yes, there is. Because if you remember, whenever you see a negative in front of the parentheses, that's the same as having a understood 1 there. So it's negative 1 times 2. What's a negative 1 times 2? A negative 2. So it's the same answer all 3 ways. Okay. This one here is going to take practice to get and to understand. I do not expect you to get that one right every time for right now. This is going to be the difficult kind of problem. It will take time for us to get, and we will practice on working how to get it right, okay? All right, so continuing on. Ooh, look at there. We're at the problem set. So what are we going to do for homework? Oh, man, Mr. Hale, that's such a great idea. Let's finish for homework. All right, you're going to do number 1, problems 2 through 4. That's going to be classwork. Okay? Depending on how things go, we'll decide from there. But for right now, this is the way things are going to work for tonight. All right, so again, you got multiplication on Sunday. You got the division tonight on Monday. We still got a lot of things left to do, so just be patient, all right? So you guys have a good night, and I will see you bright and early on Tuesday. 8-minute long video.